Determination of pKa value of weak acid. In this experiment, you have to determine the strength of weak acid. What is weak acid? Weak acid is one which dissociates partially. What is pKa? pKa means it is a negative logarithm of base 10 of Ka. Ka means dissociation constant of weak acid. What is the dissociation constant? It is the ratio of product of molar concentration of products to the molar concentration of reactant. Let us take an example of acetic acid which dissociates partially into CH3COO minus plus H plus ion. If you apply the law of mass action to this equation, you will get product of molar concentration of products to the molar concentration of reactant. This equilibrium constant represents the dissociation constant of weak acid. Hence, this K is called as Ka. The Ka value of this acid is 0.0000016. The value is very small. For our convenience, we are expressing the strength of weak acid in pK scale. Experiment is determination of pK value of weak acid. pK value of weak acid can be determined by measuring pH of the solution. pH of the solution is measured with the help of ion selector electrode, that is glass electrode, and reference electrode is calomel electrode. Here you have to use this combined electrode. Combined electrode means is a combination of glass and calomel electrode. We will provide the weak acid in 100 ml beaker. First, wash this electrode with distilled water. Then immerse this combined electrode into your weak acid solution and put this magnetic paddle into your weak acid solution and fill the burette with sodium hydroxide solution. Then switch on the instrument. To measure the pH of the solution, so we have to use this tablet column. Before addition of any amount of sodium hydroxide, note down the pH of the solution. It is 3.35. In each step, we have to add an increment of 0.5 ml of sodium hydroxide solution. At 0.5, the pH of the solution is 4.11. The pH of the solution is 4.48 or 49. At 1.5, the pH of the solution is 4.93. At 2 ml, the pH of the solution is 5.76. So now we can see the jump from acid to base. So at 2.5, the pH of the solution is 12.01. So this point is called as equivalence point, means the point at which the amount of the titrant added is equal to amount of analyzing substance in the solution. After the jump, take 4 more readings by adding an increment of 0.5 ml of sodium hydroxide solution. At 3, the pH of the solution is 12.38. At 3.5, the pH is 12.58. At 4, the pH is 12.70. At 4.5, pH is 12.79 or 80. Okay, now stop the titration. First switch off instrument. Press it, pull it up. Wash the electrodes and keep the electrodes in distilled water. Okay. So using this data, we have to determine the pK value of weak acid. To determine the pK value of weak acid, first we have to find the equivalence point. Equivalence point can be determined by using derivative graph. So for derivative graph, we have to do some calculation. For 0, there is no difference of pH. Similarly, there is no difference in volume. At 0.5, the difference of pH is 4.11 minus 3.35. We have to write. At 1, the difference of pH is 4.48 minus 4.11. So like this we have to calculate the difference of pH. Difference of volume is 0.5 because in each step we have added an increment of 0.5 ml of sodium hydroxide. Then divide delta pH by delta V. So we will get the values for delta pH by delta V. So you have to write here. Then plot the graph of delta pH by delta V versus volume of sodium hydroxide. So delta pH by delta V values along y-axis and volume of sodium hydroxide along x-axis. For 0 there is no value. For 0.5, so somewhere here, so put a cross mark and round it off, circle it. At 1, put a cross mark and circle it. At 1.5, at 1, at 2. So at 2.5, so we observed the change in pH from acid to base. At 3, so we get point here. At 3.5, somewhere here, 4 and 4.5. Now, to connect these points by freehand, then use scale to connect these 2 points. A straight line with help of scale, and one more straight line this side to connect these 2 points, and for these points with the freehand. Now volume corresponding to the maximum gives the equivalence point. So this is the equivalence point. The equivalence point means the point at which the amount of titrant added is equal to amount of analyzing substance in the solution. In this experiment, at equivalence point, you observe the change in pH from acid to base. The second graph is the pH versus volume of sodium hydroxide. For 0, the pH of the solution is 3.35. At 0.5, the pH is 4.1. At 1, the pH is 4.48. At 1.5, the pH is 4.9. At 2, the pH is 5.76. At 2.5, the pH is 12.1. At 3, the pH is 12.38. At 3.5, the pH is 12.58. At 4, 12.7. At 4.5, the pH is 12.8. Now for these points, with a freehand, now to connect these 2 points with help of scale, again freehand for these points. So we have determined the equivalence point from the first graph. So it is 2.5. Now draw a vertical line exactly at 2.5. So this is the equivalence point. Now divide this equivalence point by 2, so we will get 1.25. So here is the 1.25. Now draw one more vertical line at 1.25. So this represents half equivalence point. Half equivalence point. Now this vertical line, they intersect this curve at this point. Now draw a horizontal line from the point of intersection to y-axis. So this horizontal line intersects this y-axis at this point. The pH at this point is the pK value of weak acid. Y at half equivalence point, the pH is equal to pKa. According to Henderson equation, pH equal to pKa plus log of base 10 of concentration of salt by concentration of acid. At half equivalence point, the concentration of salt is equal to concentration of acid. That's why the pH is equal to pKa. Ka value of the acetic acid is 0.00016, whereas the pK value of the same acid is 4.7 according to this graph. So that's why for our convenient we are expressing the strength of weak acid in pK scale. It is 4.7 for acetic acid.